This question states that square root of x plus y plus the square root of x minus y plus the square root of x minus y minus the square root of x plus y primed equals 0, where x is greater than 0. So this looks homogeneous, but we're going to check by taking the f of t, x, and ty. And when you do that, you get the square root of t times x plus y plus the square root of t times x minus y plus the square root of x minus y minus, t times x minus y minus square root of t times x plus y primed equals 0, and we know that it is homogeneous based on this, and its alpha is t, because it's t to the 1/2, our alpha equals 1/2. So get that y primed equals negative x plus y square root plus the square root of x minus y over the square root x minus y minus the square root x plus y, and y primed equals negative x minus y plus x plus y minus 2 square root x squared minus y squared over x minus y minus x plus y. This equals negative 2x minus 2 square root of x squared minus y squared over negative 2y. And we know this because when you multiply the denominator by the numerator, you end up with that at the end. So y primed equals negative 2x minus 2 square root of x squared minus y squared. Right now I'm just reiterating what was written over there, over negative 2y. And because it's homogeneous, you're going to replace the y with vx and the y primed with v primed x plus v. So v primed x plus v equals, negative 2x minus 2 square root x squared minus v squared x squared over negative 2vx. From here, get that v primed x plus v equals negative 2x minus 2x square root of 1 minus v squared over negative 2vx. You can cancel out the negative 2's and the x's, so negative 2x, negative 2x. You end up with v primed x plus v equals square root of 1 minus v squared over v. From here, get the v primed x equals square root 1 minus v squared over v, because when you subtract v from this side and move it on this side and multiply that by the denominator to make it part of the original fraction, you end up with negative v squared. So from here, to get v primed on one side, we divide both sides by x, and we end up with v primed equals all of that up there, 1 minus v squared over v times 1 over x. And you end up with v over 1 minus v squared square root minus v squared dv equals 1 over x dx. You know this because v primed equals dv over dx. And you can break this fraction up into v over square root of 1 minus v squared minus, or plus 1, sorry, minus v over the square root of 1 minus v squared. dv equals 1 over x dx. And if you look at this, you'll realize that you can use substitution and substitute this down here as 1 plus u, or you can substitute this as being u technically. So u would equal square root of 1 minus v squared, and if you take the derivative of it, your du would end up being v over square root of 1 minus v squared. So what you can do, so what you can do is have a quick correction. This ends up being 1 over the square root of 1 minus v squared plus 1 minus v over 1 minus v squared dv. I messed up in doing my partial fractions, but it's fine now. So if you notice, we can substitute this for u, this 1 minus v squared for u, and this v over square root of 1 minus v squared dv can be our du. So we take 1 over 1 plus u integrated minus du, du equals 1 over x dx, and you end up with natural log of 1 plus u equals natural log of x plus c. So you plug back in, you get natural log of 1 plus the square root of 1 minus v squared equals natural log of x plus c. You don't need to do the absolute values because it was given that x is greater than 0, but you can. And then you know that you just plug back in for v, you get the natural log of 1 plus the square root of 1 minus y over x, so y for x squared equals the natural log of x plus c, where c is an arbitrary constant.